Now we did a, well, I shouldn't say we, I did a very maybe bad job of doing the SOHCAHTOA right before AZ Merit. Because remember, the day that we did SOHCAHTOA, I taught you 4 concepts in one day, where like if we had time, I would have taken a day for each one so we could practice. So now I'm going to slow down just a little bit. I thought about the mistakes that were being made when we were practicing in class, and that's what we're going to start off with. So when it comes to SOHCAHTOA, a big part of it is making sure that you label the sides correctly. So that's what we're going to start off with. In each triangle, on the notes right there, I have a specific corner that's been marked off. It's got a little curl, like an angle mark, the kind you saw in geometry. Now the reason why that's important is because that determines how we name some of the sides. Now before we do this, so it says up at the top what sides we want you to label. So we always start with the hypotenuse. The reason why is because the hypotenuse never, ever, ever changes. It's always across from the box, and it's always the longest side of your triangle. So I'm just going to put an H on this side. Now the next thing that I told you was when you're doing your labeling, always do the opposite second. The reason why is because the opposite side is the only side that is not touching the little mark. So the angle that you got the number or the X or the mark in, the opposite side doesn't touch it. This would be the opposite side because it's not touching the mark. So that means this has to be opposite, and then that forces that to be A. Now you can also see, hopefully, that you should be able to do this no matter what your triangle looks like. So I could take the triangle and spin it around and flip it backwards and make it upside down. It shouldn't matter because all of the rules stay exactly the same no matter what the triangle looks like. So in the second one, I'll put the mark over here so it's backwards. Hypotenuse doesn't change though. Hypotenuse is always here. So the opposite side. The opposite side is the one side of the triangle that is not touching the corner where the angle is marked. So that means this one has to be the opposite. If that's the opposite, well then that forces the third one to be the adjacent side. So I'm going to give you about 20 seconds. I want you to label number 3 for me, if you haven't already. We have to get this part right because the solving part depends on it. Okay, here's what you should get. If this is marked off, this is the hypotenuse because it's across from the box. This is the opposite side because it's the only side that's not touching where it's marked. And when I mean that, look at this. This is what I mean by that. See, that side and that side, they touch the mark. So neither of these sides are the hypotenuse. So that's the only one over here that's not touching the mark. So that's opposite. And then this right here is the adjacent side. Okay. So once we know how to label it accurately, that should help us be able to set up some equations to solve for any missing side. So it says use the diagram to find the missing side and the angles rounded to nearest tenth if necessary. Okay. So if we follow the same strategy as before, this is the side that has the little curly thing in it, the angle mark. So I'm going to label this as the H. That makes this one the opposite. And then this one would be the adjacent. Now here's the thing about this one though. Remember when we did the AZ Merit practice, one of them was always blank? So we scribbled it out. Well, I'm going to tell you something just a little bit different this time. So let me go into the SOHCAHTOA thing. So I just adjusted how I wrote it also because now that it's set up the way the fraction should look once we pick it. Okay, so this one has a 15 in it. That means we have to use it. It has a number, we have to use it. We have to use the 20, and we just need to pick a side. Like, which one would you rather solve for first? The R or the S? Okay, R. Okay, so if we're going to solve for the R, that means we have to use the 15, and we have to use the O, or the opposite side, which is the R. So the only trig ratio that uses the O and the H is this one. So that tells us to use the sign. So we're going to set this up as the sign, and inside of here is always the degrees. The sine of 20 is equal to. This is the fraction. The O goes on top and the H goes on the bottom. So the O is the R, the unknown, and then the H is 15. So anytime you're solving for the missing side, all you have to do is cross multiply. So we put this over 1. We multiply R with 1, so that's R. Multiply 15 with the sine of 20. So it's 15 times sine 20 degrees. And now it's just calculator work. Probably a decimal, I'm guessing. What is it? So what? So you got 13?
I got 13.7.
Is everyone getting 13? So here's what I want you to do. Go into the setup. We need to make sure that our calculators are set in degrees. So hit the setup, go down to where it says angle, and make sure it says DEG. Because if it doesn't, that's going to give us the wrong answer. So it's house. It's shift, menu, and you use the arrow buttons down to where it says angle, and I think it's F1. Yeah, that's what I'm saying. That's why I didn't think it was right. Because I saw someone get 5, and then you're telling me 13. So someone's definitely, it's not you, it's the calculator. So just remember this, you guys, because this is big for the test we're going to take. If there is a pi inside of the sine, cosine, or tangent, then the calculator needs to be in radians. If it's degrees, then the calculator needs to be in degrees. What do you say?
Yeah.
Same thing?
Yeah, okay. Angle.
Yeah, change your angle into degrees if the sine, cosine, or tangent has degrees inside of it. So I think the R side should be 5 point.
What did you say about the 5?
Okay, this is what I'm saying. I'm talking about specifically in here. If that has a pi on it, that means your calculator needs to be in radians. If it has degrees, then your calculator needs to be in degrees. And we're gonna talk more about radians, because remember I did kind of a quick job just to make sure you've heard the words and you're not like all scared on AZ Merit in case that word came up. So we'll talk about radians again. But I think, what was it, 5.13? Okay. Now they want us to find all of the missing sides. So we got to find the other side now. Now if we're going to find the other side, we could again use a trig ratio. We'll just use a different one. So there's no doubt about it, we have to use the 15. But this time we're going to use the A. So we have to use the H and the A. The only trig ratio with an H and an A in it is the cosine. So it'd be the cosine of 20 degrees equals, we're doing cosine right now, so the adjacent side on top of the hypotenuse. The adjacent side is the missing side, and the hypotenuse is 15. So you can see, like, it's almost the same exact problem. We're going to cross multiply the same exact stuff. S times 1 is S. We have 15 times cosine of 20. And then that goes in the calculator again for another decimal. 14 point. Yeah, I'll put 14.1. So the directions say find all the missing sides. Now we have the 2 missing sides, and it also says to find the missing angle. Now there's a missing angle in that corner over there, but we don't have to use SOHCAHTOA to find it because SOHCAHTOA is only used if you only have the 90. I have the 90 and the 20 though, so I don't need to use SOHCAHTOA. I can just use basic geometry facts. Triangles need to add up to 180, right? 90 of them are in that corner, and there's another 20 showing there. So 90 and 20, that's 110. So that means angle S has to equal, oh my God, 70 degrees. And guys, that question, very similar to what you're going to see on the test. The test is going to make you find the missing side and the missing angle. So it should be something that you should be able to do. Now, because we've already talked about this, like our assignment packet has a 13.1 well, chapter 12.1a and a 12.1b. The first part is this stuff. The second part is what's on the next page. It's the applications, the word problems. I'm going to try to break it down to you like as simple as possible though. So in order to do some of these word problems, you may or may not see some of these keywords. They are important because they determine how you draw your picture. But I'm also going to tell you sort of, kind of how to cheat. Kind of. But it's not cheating because it's actually some geometry rules that you probably forgot anyways. So you may read a problem or encounter a problem that talks about the angle of elevation. Think about what elevation is. To me, elevation is like taking the elevator and usually take the elevator up, right? So when you see the angle of elevation, that means that you're going to sort of look up and you're going to put the angle in the corner because this is all still triangles. Every situation and every scenario I'm going to give you, you have to draw a triangle. So we need to know the angle. So the angle of elevation is going to go in the corner. That's not the 90-degree angle, but it's still at the bottom of your triangle. So that's where you put the angle of elevation. Now I want to show you this, the angle of depression. Now think about the word depression. You think of someone that's like kind of down, right? That's exactly what the picture is like. If you have an angle of depression, it's based off of your horizontal line that's kind of like where your eyes are at. And then this is the line of sight. So it's like basically the line that you would follow to get to where you're looking at. The angle of depression is the angle that's formed in this triangle. Now, me personally, you guys, I'm lazy. I'm not going to lie. My triangles all look the same. I don't care what the problem says. In an angle of depression problem, when they tell you the angle itself, it's supposed to go in this corner right here. But here's what I want to tell you. When I draw my pictures, every one of my triangles looks exactly the same, and I could care less if it says angle of elevation or angle of depression. So just a quick summary of what these mean. This means you're looking up. This means you're looking down. But I'm going to show you some stuff that I do that I think makes it a whole lot easier. So basically, like, no matter what, I just draw my triangle like this every single time. Even if it says angle of depression. Here's why. According to what they're saying up above, the angle of depression is supposed to be the angle that's formed by this spot right here, right? Because the triangle is kind of upside down. But there is a fact in geometry that has to do with parallel lines. I don't know if you guys are going to remember this picture. There's parallel lines, and this is the transversal. In a picture that has parallel lines with the transversal, you get a lot of angles that are the same. They have names to them like alternate interior, alternate exterior, and all that stuff. So basically, like, this angle that's marked off for the angle of depression, it's going to just go on the bottom anyways because it's an alternate interior angle. They're the same. That's why I always draw my triangle the same. And no matter what it says, I just put the angle in the bottom corner, if it's angle of depression or angle of elevation. So here's what we're going to do. We're going to do a couple of problems together and use SOHCAHTOA to solve it. It says a tree casts a shadow 12 feet long. The angle of elevation from the ground to the sun is 42 degrees. How tall is the tree to the nearest foot? Okay, so I'm going to draw a triangle. Why? Because they're always triangles. The triangle also always has to have a box. As a matter of fact, I'm going to make my triangle so it's got 3 different colors to it. Because the hardest part to this is figuring out where the stuff is supposed to go. So I've got 3 different colors up here. It says a tree casts a shadow that's 12 feet long. In my 3-colored triangle, which one is going to be the shadow? It's going to be the green one. So we're going to label this as 12. It says the tree casts a shadow that's 12 feet long. If the angle of elevation from the ground to the sun is 42 degrees, so I got to put 42 degrees somewhere. Which corner? Tell me the 2 colors. Blue and green. Perfect. And you remember what I told you earlier? Even if it would have said angle of depression, I still would have put it in the bottom corner because it's an alternate interior angle. Yeah, it's going to be the same no matter what. So 42 degrees. And then they say, how tall is the tree? What color would the tree be here?
Right.
It's the red one. So that's where the X goes. And that's how we approach every single problem. We draw a triangle, and we try to match up the different parts with what it's explaining in the paragraphs. So now we use SOHCAHTOA to solve it. So let's see. This is the H. This is the O. And this is the A. We're not going to use H because we could care less about that blue line. That's not what the question is even asking us for. So I have to use a trig ratio that uses the O and the A. Which one is it? The sine, the cosine, or the tangent? It's tangent, yes. So it's going to be the tangent of 42 degrees is equal to, and it's TOA, so O on top of A. So it's the X on top of the 12. And these problems are always just cross multiplying. X times 1 is X. 12 times tangent is 12 tangent 42. And then it goes in the calculator and we get a decimal. 10.8. So X equals 10.8 feet. Remember, it's a word problem, so we got to attach units.
So that means that. Oh yeah.
So a tree that's 10.8 feet is casting a shadow that's 12 feet. Because this is where the sun is at. I shouldn't have put that. It looks like a hole. I'll make it into a sun. That's a stupid sun. I shouldn't have done that. I immediately regret my decision. Okay, let's try it again. I'll give you some practice also, but let's try this again. It says you're parasailing. You guys even know what that is? It's when you're on the boat and you're tied into a string and you have a parachute on and they drag you everywhere. Sounds fun, right? Okay.
We done it.
Huh?
We done it.
Once. Then I woke up.
We.
Fix this up. Okay, I start off with a triangle because they're always triangles. It says you're parasailing. The line to the parasail is 650 feet long. What color is the line that goes to the parasail?
Blue.
This is the string that's tied to the boat and then to the person.
Blue.
Yeah, it's the blue line. So it's 650 right here. It says the angle of depression from the parasail to the boat is 55. Remember what I told you earlier? No matter what, even if it's angle of depression, we're going to stick it right here. Because, I mean, technically the picture is supposed to look like this, but I don't like drawing it upside down. I always draw my triangle the same. So using alternate interior angles, I know that that's still 55, so it doesn't matter. It says, what is your altitude? What color is going to measure the altitude of the person on the parasail? Yeah, it's the green one. So we put the X right here. The black one, that would just represent the distance from the boat to where you would hit the water, I guess. I don't know. Like, God forbid that happened, but parasail fails. So again, SOHCAHTOA, we're labeling all three sides. This is H, angles in that corner, so this is O, and this is A, which we don't need. So we need something with the O and H. It's going to be the sine. So it's the sine of 55 equals X over 650. And then again, these are always just cross multiplying. So X equals 650 times sine 55. How much? 532? So that guy's way up there. 532.4 feet above the water. You're like almost hitting the sun. I'm just kidding, not that high. So I want to give you guys a chance to try it. It's the only way you're going to get better is if you do it.
Where'd you put it?